Good afternoon, everyone. My name is Hari. I take care of sales and strategy at Binox. Today, I'm here to talk about some of the CDN challenges at ISP. I think it's a good slot to talk after Paul here. So the reason why we can talk about it so that you can also relate to what we do. So we provide network analytics. So we inspect IP traffic and provide analytics for our customers, which are usually ISPs. So we can provide some insights of to how there are certain challenges what CDN faces. Since, let's say, we are moving more into edge computing, so how with some effective communication and collaboration, I think these challenges can be addressed jointly. All right, so there are a few focus areas which we usually have between CDN and ISPs. I think the two major boxes here are capacity and localization. So capacity more of a negotiation because there are some conflicting interest for CDNs and ISPs, while localization more of aligned interest. So that's a joint discussion, I believe. So some of the topics in capacity is, of course, the utilization versus headroom. As I said before, this is definitely a conflicting priority for a CDN versus an ISP. And the second one is what's like the multi-CDN versus stability. I think we also know how it is happening nowadays where during major sporting events, sometimes CDNs have volatile traffic patterns, which gives us a lot of, let's say, uncertainty. And sending traffic through indirects for overflow, as I said before. This could be expensive as well sometimes for the ISPs and caches. So these are the main topics in terms of capacity. And in terms of localization, as I said before, it's aligned interest because you can deliver traffic close to the end user to minimize round-trip delay or round-trip time, however you want to call it, latency. Avoiding unnecessary backhauls to minimize the backbone load. And yeah, keeping delivery profiles stable, which I think it's also somehow interlinked with capacity as well. So just to talk about the capacity challenges here, I think what we always feel that when you plan for capacity as an ISP, joint planning can definitely reduce, let's say, investment needs and also improve resilience. So let us look at what are the upside and downside, right? In terms of talking about how the trend is about edge computing now. So it's great for customer experience, as we all know, and that's mostly why we want to move to edge. And I think in terms of cost as well, you can share the distribution cost to an extent, so which is great for both ISPs and CDNs. But then the downside here is you need to have more headroom per node, I think, for traffic spikes. And the failover concepts are definitely poorly aligned because the CDNs, they have a different failover concept compared to an ISP, and there are, let's say, sometimes miscommunication, which again brings us to the existing problems or the challenges which ISPs face. But then, in summary, what this will drive towards is it will shrink backbones because since it's coming to more regionalized traffic distribution, we'll probably have, or ISP will probably have, let's say, less capacity in their backbone links. Let's say once the trend dies down, hoping it doesn't, your backbone will be very lean, and at some point you wouldn't be able to handle the overflow. And localization and stability, which we spoke about before, I think time and again, will become key requirements. I'll probably give you a short example of why it is key. So This is a screenshot from one of our customer deployments, and of course, with their consent. So you can see here, we are able to, or a particular CDN is sending traffic to a particular region here, but through different ingress points here, right? Like these ingress points are usually different regions. So you can see here the traffic is delivered or egressing into, let's say, this region, but with various regions. So let me explain how this looks in terms of the CDN's perspective. So it could be many number of reasons. It could be that they have content and some part of the content in a place and some part of content in a different region. So they're basically trying to send traffic from different regions. Or it could also be because they're just trying to, let's say, do a bit of content sharing, right? So, but what we realized when we put that in terms of time series and volume share over a particular week, this is, I think, for a week, yes. So you could see that it is actually random. So the colors here represents different sources or ingress, like we saw before, and you could see that it's definitely random, but it's also because what they're trying to see is that, or at least what they're asking ISPs to have, is to have backbone capacity in 3 different regions. So you can see here, the first half of the week, there was traffic coming into the trunk from the west and the north region, while you didn't see that in the south. But then slowly at the, let's say the next half of the week, you see the traffic coming in from south region. So this basically makes the ISP, or at least wanting to have 3x of capacity rather than normal, let's say 1x, because there's no real data exchange between ISPs and CDNs, so which leads to a lot of confusion, right? So moving on to the localization challenges. So I think we spoke about Edge and how they're investing in terms of regionalizing servers. But what is also important is to make sure the traffic is also being regionalized and not just the edge, and not just getting the edge to be hooked up into your, the server clusters to be hooked up into your network, but then the traffic is also coming from different, or the nearest region, like the nearest server cluster. So let me tell you why it is important, right? So you can see here, the real client sits, let's say, for example, in Berlin, and there are different server clusters around Germany for that particular CDN. So you do see that this metric is basically a representation of hop count in kilometer, and you can see from the different regions, it has to be served from the server cluster which is near to Berlin. But then there's also possibility of the traffic being served from Frankfurt or Munich, which is not really great for your latency and the round trip delay. As you can see here in terms of hop count in kilometer, it doesn't really make sense, right? But then how does the CDN get this information? So that's the big question here. So there are certain workarounds or certain solutions which CDNs have right now to resolve this issue of where to serve the traffic from because of different server clusters in different regions. So I'm going to explain the ones which is in the highlighted ones a bit more in detail. So I'll probably just address the 2 which is here, which is Anycast. So as we all know, Anycast is basically it's passive mapping, right? Like we don't actively do anything about it. We allow the network to do it, and the DNS-resolvers to do it on their own. But the downside here is there's no failover. So once, let's say, if it goes into that particular resolver, and if there's no traffic, then there's no coming back. And yeah, another thing is there has to be content everywhere. You have to load your content at every particular cluster, which is, again, a matter of capacity here. Yeah, there's no load control, and it ignores all the outbound policies. The other one is round trip measurement. I think most of the CDNs uses it probably. So I mean, round trip works definitely well for most of the CDNs who have millions of, let's say, not millions of locations, but millions of pings at one point, and helping them to find the lowest RTT path. But what it happens is it's misleading for asymmetrical paths. And I'll also probably explain what we say here is the external BGP is not actually equal to the internal BGP, which an ISP has. So the other ones are identifying DNS resolvers to locate users, and geolocating users with internal or external databases. So let's probably see that in detail. First, identifying DNS resolvers to locate users. I think it's quite functional for most of them, because we only have few addresses to monitor, so it's quite easy. And let's say the DNS locations are fairly stable, because you update a DNS, you update a location or include a location, let's say every other year. So it's also easy to communicate. And then, yeah, you don't need ECS here, which is again a great and probably reduces the complexity here. But then the downside here is the DNS resolvers, they always get load balanced and misconfigured. I'll give you an example of why that happens, or how you can probably have a workaround for that. And the fallback resolver's location can be far off, which is true, because sometimes you can think that, yeah, okay, fine, we have a location probably in Munich, but then the fallback resolver is somewhere in Berlin. Then it again adds to, let's say, your latency, right? And I think this is a very good question, and how it works for certain DOH, which is DNS over HTTPS, right? For 8.8.8.8 and also Cloudflare is 1.1.1.1. But I think it also kind of fails for smart TVs as well, because the DNS which comes for a smart TV, which is hard-coded sometimes, and it's usually, let's say there are many providers in the market, and it's usually from which region they are present. So there could be a South Korean DNS in a smart TV, and which basically fails when you have to, let's say, send the traffic to that particular client. So one really good example here with how it's let's say, a downside of identifying a particular client with a DNS resolver. So in this example, one of our customers had configured their resolvers in a kind of a round-robin load balance, wherein they said, yeah, let's for load balancing, we'll have different DNS resolvers in a fluctuating or in a dynamic way. But then what they didn't realize is that how it impacts CDN mapping. What happened here, as you can see, is that the content is being delivered from different locations, to reach a particular client. And this is because of the way they have configured. Normally, without having this kind of visibility, you wouldn't be able to tell the problem, right? Like, we would always think, okay, there's a lot of round-trip delay here, latency here, so they'll usually try to optimize their radio access network sometimes. So I think with this kind of visibility, what you can probably do is to figure out it's a problem with the DNS resolvers or the configuration of DNS resolvers. And once they found out the problem and said, for this particular region, this is going to be their DNS resolver, and the traffic is going to come from here, then you can see how the traffic is stabilized, and it is coming from a particular region. So this is one of the, let's say, examples. And in the second example, you can see here, I mean, let's say there are some configuration mistakes we make. And ISP had accidentally configured, let's say, a remote resolver as primary. Again, CDN not being aware of it, was using remote servers for delivery. So the traffic was coming in from a different region. So this, again, kind of asked, ISP started asking questions as to why the content is coming from here, and then realized that there was a mistake from their side. As you can see here, how the traffic pattern slowly changed. I mean, we have to give you a 2 months view here, so that, because it usually takes some time for them to figure out what's the problem. And then you can see how slowly the traffic patterns change, and it is coming from the same region where the client lies. So next challenge or the workaround which we have is, let's say, getting external or getting access to internal and external databases. I think the databases are broadly available, as we know. There are multiple databases which are available, and it's easily accessible, so that's great. It is straightforward, and it works usually. And the great thing is you don't need any engagement with when you're an ISP and also for a CDN. So because there are multiple, especially for big CDNs, they have multiple peering, so they can't really engage with everyone. But the downside is, so the eBGP aggregates is definitely not equal to the IGP subnets. I think I'll give you an example of what I'm talking about here. And there's also a delay, usually, for reform subnets. And the geo distance, what you have with these databases, is definitely not equal to network distance. I'll give you a beautiful example there. And it ignores round-trip reality, which is the outbound path for a particular ISP. And it is often inaccurate, at least in our opinion. So let's see why, right? So the first example is the IGP, the eBGP versus iBGP. So what we have taken here is usually /12. It's about 1 million, let's say, IPs. And then based on the IP geo, the geolocation, it takes Braunschweig, right? Like that's the IP geo for a /12 coming out of Germany. But then if you see the iBGP, which is your internal configuration, so you could see that the /12 has mainly 220 prefixes, and these 220 prefixes are allocated in different regions in Germany. So Munich, Stuttgart, Nuremberg, name it, right? And this goes to show how, with just geo IP data, you cannot really route traffic, and it is quite hard to locate the region. It's definitely eye-opening. So this is, again, in terms of update delay. You can see here the traffic is delivered from a remote source to 3 local BNGs. So they have reformed because, let's say, they allocated a /20 to another region, and now once it has been reformed, it took the CDN 2 weeks to notice that they have reformed the location, and then route the traffic accordingly. As you can see here, in the end, how the traffic has basically changed. The patterns have changed, at least. So this is a great example of how we cannot really assume the geo distance to be the same as the network distance. So let's take an IP prefixes which has been identified for Heilbronn, which is a city between Stuttgart and Frankfurt, if I'm right. So if you take the geo distance round trip, what it is being given here, so you can see here Frankfurt to Heilbronn is 234 kilometers. And let's say for a CDN, the next closest server is Munich. And from Munich to Heilbronn, it's 414 kilometers. So if you look at the data here, this is easily the best choice, right? As you can see here, this is 77% more. But when you consider the network distance round trip, so you can see here the traffic from Frankfurt goes to Stuttgart, and then it travels to Heilbronn, right? So which is 392 kilometers. And if you take it from Munich, it goes from Munich to Stuttgart and then to Heilbronn. It's still 462 kilometers. So this is still the best choice if you have to route the traffic based on the geo location. But then when you consider the actual the round trip, so the network topology is different for different ISPs. And if you take the Frankfurt route, you can see that the traffic which comes into the network comes via Frankfurt and then to Stuttgart and to Heilbronn. But then, because it's a round trip, the traffic from Stuttgart, for some reason, for this particular ISP, goes to Munich and then to Frankfurt. I mean, it has to go to Frankfurt because that's where the session started. So considering the round trip, you can see here, it takes 735 kilometers. So this is more than 60% of the best choice what the Geo IP provided. So seeing that in actual topology here, so you can see here, this is the in traffic coming in from the CDN to ISP. And you can see most of the traffic from Frankfurt is coming in to Heilbronn directly. But then when the traffic goes out, it goes out from Heilbronn to Munich when it has to reach Frankfurt. So that's something which is not considered when a CDN routes the traffic. So, which, I mean, this is basically ignoring the round trip reality here, right? So this is, I think, one of the examples which we thought that we could work on a solution. And what we did was we made sure to have a real-time data exchange between ISP and CDN. So what we do is, since we sit on the network operator, we can see their topology, and with, let's say, a certain metric data exchange via API, we can provide CDN real-time information about, let's say, each IP, and this is how it looks. So as you can see here, the metric basically considers hop count, kilometer, capacity, and utilization. And then each of the, what you get here is an Excel sheet with, for each of the prefix, which has, let's say, all of the, and for each of the routers, you'll get a metric. As you can see here, for bigger networks, there are multiple prefixes and hundreds of routers. So this information is updated in real time, so that the lowest score is probably the best path for a CDN to reach their client and their subscriber in an ISP network. So that, I think, brings me to the end of my presentation. Sorry for taking more time. So I'm happy to answer any questions.
Do we have any questions for Harry? OK, thank you very much.
Thank you.